Did you know that topic 15.1, the refractory period and its link to impulse frequency, is literally one of the most misunderstood areas in the entire Cambridge biology syllabus? Seriously, this isn't just some minor, tricky concept. This is the exact spot where candidates are bleeding crucial marks that completely dictate your final grade boundaries. So we're going to fix that right now.
Think about it for a second. What do you think is the #1 mistake costing you marks on the refractory period? Well, I'll tell you right now. It's actually not a lack of memorization. You guys probably know the textbook definitions back to front, right? The real problem is this tiny, almost invisible error in how you apply what you know to the actual exam paper. And honestly, it causes a massive shock to your confidence when you finally see that grade.
Check this out. This is a direct, unfiltered warning, straight from the Cambridge Principal Examiner report. They spell out exactly what goes wrong, saying, students confuse cause and effect in 15.1, refractory period. Answers are not specific to the context given. Okay, so this is the highest possible authority telling us precisely what they want to see, and exactly where thousands of students are just falling short.
Basically, this means your usual revision strategy, it's probably failing you. If you're just sitting there highlighting textbook pages, you gotta stop aiming for superficial breadth. The academic benchmarks for Cambridge biology absolutely demand logical, structured reasoning. The assessment framework explicitly prioritizes analytical depth over just, knowing a wide range of basic facts. If you just memorize that voltage-gated sodium channels close, but you can't apply that to a weird, unfamiliar context, you're missing the whole point.
So we really need to tackle the top 3 traps examiners are laying out for you. First up, confusing cause and effect relationships. You have got to know exactly how the absolute refractory period limits the maximum frequency of impulses and not the other way around. It's a one-way street. Second, forgetting to check units and terminology. Precision is literally everything in A-level biology. And third, providing generic, non-contextual answers. If you can just avoid these 3 specific mistakes, that is your absolute best quick win to securing those top band marks. Okay, let's really dive into this. In just a minute, I'm going to show you this hidden examiner clue that will completely change how you answer these questions. But first, you need a framework to actually spot that clue. We call this the method-marked strategy. It's basically a system where marks are rewarded for your procedural process and your scientific reasoning. It's going to guide you to the right answer every single time. And here is that exact systematic methodology you need for complex biology problem solving. It's built on 3 really straightforward steps: deconstruct, solve, and evaluate. If you apply this simple framework to every single exam question you face, you completely remove the guesswork. You end up building this highly structured, evidence-based answer that examiners absolutely love to see when they're grading those tough impulse frequency questions. All right, step 1 is to deconstruct. When you're staring down a tough question, your very first move is to deconstruct the prompt and extract the relevant data straight from the stimulus materials they give you. You have to identify the given info and break it down into logical steps. Don't just sort of glance at a graph showing action potentials per second, right? Actually dissect the intervals before you even think about picking up your pen. Moving on to step 2. This is where you solve. You need to take your analytical framework and execute it systematically, using clear notation. Basically, you have to present your scientific reasoning using the absolutely correct Cambridge terminology. If you're talking about action potential generation or the absolute refractory period, use the exact phrasing from the mark scheme. Keeping your steps clear, logical, and precise here is what guarantees you those method marks. And then we hit step 3, which is honestly the most critical part. Evaluate. You need to check your answer and ask, does this actually make sense? Evaluating evidence quality means identifying any limitations in the data, spotting assumptions that might have been made in, say, a nerve fiber experiment, and considering alternative interpretations. How do those things affect the final conclusion? Making justified recommendations based on evidence, that is exactly what separates a good student from an elite one.
It really all boils down to evaluative thinking, which is just the process of questioning assumptions, considering different perspectives, and backing up your decisions with rock-solid evidence. The syllabus makes it super clear that top-performing candidates always show this connected, conceptual understanding, and it's exactly this type of thinking that transfers flawlessly when they throw a completely weird, unfamiliar context at you in the exam.
And this brilliantly illustrates the difference between an average response and a high-mark strategy. Look at the flawed answer. It just generically defines the refractory period as a rest phase and completely ignores the specific neuron mentioned in the prompt. But the top band answer, it applies the concept directly to the data. It explicitly explains that the stimulus intensity can't increase the impulse frequency beyond a certain cap because those specific voltage-gated sodium channels are still recovering. Nailing that exact cause and effect is what proves your evaluative thinking.
So please, treat this as a massive examiner alert. The absolute classic mistake is giving generic answers. You must always link every single point you make back to the given scenario. If the question gives you a specific case study or maybe a practical investigation design, your scientific reasoning has to be anchored to that specific evidence. Never just leave your answer floating out there in theory land.
Now, let's talk numbers, because statistical analysis bridges directly into biology here. When you're handling experimental data about impulse frequency, you have to select the correct statistical test. It's a simple checklist, really. Use a t-test when you're comparing means between groups, use chi-squared for categorical data analysis, and go with a correlation test when you need to establish relationships between two variables. Knowing exactly which mathematical tool to pull out of your toolbox is a huge advantage.
Also, don't forget that the theoretical architecture of Biology 9700 absolutely requires integration. Cross-topic connections equal top marks. Principal examiner reports point out all the time that candidates who reference connections between the refractory period and other areas of the syllabus just score way higher. For example, try linking the refractory period to synaptic transmission or maybe sensory receptor adaptation. Remember, you're not just studying isolated topics, you're mastering one big connected system.
Okay. Let's do a super quick recap of the core takeaways from this explainer. To truly master the refractory period and impulse frequency, you've got to use that deconstruct, solve, evaluate framework. Always link your answers to the specific context they give you. Make sure you select the correct statistical test when you're analyzing data. And most importantly, really master those specific biological cause and effect relationships so you never mix them up when you're under exam pressure.
But here's a critical diagnostic question to leave you with. What if you do all of this perfectly, but you completely misread the command word instructing you how to actually use this framework? Whether a question asks you to explain, describe, or evaluate completely dictates the mark band you fall into. If you miss that, even the absolute best framework won't save your grade. So make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. And go watch our next explainer on command words right now to uncover this hidden cause of dropped marks. See you there!